Good evening. Welcome back to the Nerdy Espresso, brought to you by Lunasta Studios. Hi, I'm Siam Ahmed, and as always, I'll be your host. It's 2025, and we are living in a golden era of AI. Hundreds, if not thousands, of AI tools have been introduced to us already. Now, some of the most popular ones, at least for me, are ChatGPT and Gemini. I also dabble with Claude and Canvas AI here and there, but that's quite normal. But AI has been around for years now, and we have seamlessly integrated into our daily lives, from major tasks to the smallest things. But here's the question: do you know how AI actually works? Now, explaining an AI like ChatGPT or other natural language processing models can get pretty complicated. So, for today, let's stick to the basics: conventional machine learning and AI models. They're the foundation of everything you see in this field. Like you use ChatGPT or Gemini or any other AI in your life, but the foundation lies there. It's true, nowadays you can build AI systems with GPT models or other work with agents, but let me tell you, if you're aiming to create real research projects or products, you've got to master the basics first. I've always believed and said before that everything boils down to fundamentals. Recently, I've watched a video on how to become a machine learning engineer in 2025. The creator shared some great books, recommendations, and a little learning roadmap. If you're interested, I've linked that video in the description. But today's podcast isn't about roadmaps, it's about how machines learn. Exactly, it's kind of ironic, like how machines learn. So let's break it down into the simplest terms. A machine learning model is just a computer that takes a bunch of inputs and provides an output. That's a high level overview, of course. Machine learning, or ML, is a branch of artificial intelligence focused on building models and algorithms that enable computers to learn from data and improve over time without being explicitly programmed for every task. You don't have to explicitly program everything that if this goes there, you have to do this and that. That happens on conventional programming tasks. Like you have to code every cases, you have to test every cases, and you have to think of the edge cases. But it's not true for AI. Think of it as teaching systems to think and learn like humans by analyzing data, like how we humans learn. There are three main types of machine learning, each with unique characteristics and applications. Let's dive into them. The first one is supervised learning. It involves training a model on a labeled dataset. And what's a labeled dataset? A dataset where both input and output parameters are already defined. The model learns to map the relationship between inputs and outputs and can then predict outputs for new inputs. So that's basically it. It just trains over the data and it just gives a test. Like this, how we learn things. Now, here's an example you have probably heard before. Imagine building an image classifier to differentiate between cats and dogs. You feed the model labeled images of cats and dogs. The model analyzes these and learns to recognize patterns. Later, when you provide a new image, it predicts whether it's a cat or a dog based on its training. Supervised learning is further divided into classification and regression, but I'll leave the technical deep dive for another day. If you're curious, I've linked an article in the description that you can explore. Now, next up, we have unsupervised learning, which is different beast altogether. Here, the algorithms works with unlabeled data. As we worked with the supervised learning, that data was labeled, and now we have unlabeled data. That's why it's unsupervised learning. So, what is use? It discovers hidden patterns and relationships without predefined output. Let's say you have a data set of your shopping history, and then unsupervised learning algorithms might group similar purchasing behaviors, identifying patterns like which items are often bought together. This kind of insight can help businesses target customers or even spot anomalies. A common technique in unsupervised learning, is clustering. Now, what is clustering? Clustering is basically grouping similar data points based on shared traits. It's kind of like just grouping based on their patterns. That's all it's about. So for example, it could segment customers into different categories based on their buying habits. Maybe a customer buy like some specific things. Maybe one customer buys milk weekly and some other buys an avocado weekly. So it can cluster them, that the people based on their buying habits. That's what clustering is. Finally, we have reinforcement learning. We are almost end to this podcast. I know it was a quick one, but let's get over it. So unlike the previous two types, reinforcement learning focuses on interaction. The model learns by taking actions in an environment, receiving feedbacks, for example, like rewards or penalties. So whatever the AI is learning, and if it's a good thing, it's the rewards, and if it's a bad thing, they receive the penalties. So as like you can treat it like a child. If a child is doing a good thing, we often give him or her a praise, give some rewards or something. And if the child doesn't behave good, then we sometimes give a penalty. So that's how a child learns about the surroundings. That's what reinforcement learning is. And based on this things, it adjusts its behavior to maximize rewards. Obviously, like human, everyone wants rewards. So that's why it tries to remember what gave it the rewards. So it tries to do their best. So a classic example is training an AI agent to play chess. The agent tries different moves, gets feedback based on the outcomes, and improves its strategy over time. Another well-known example is Google's self-driving car, where the AI learns to navigate by interacting with its surrounding. Reinforcement learning is particularly exciting because it enables AI to tackle complex tasks like gaming, robotics, and autonomous systems. Maybe like if you have supervised learning, you really have to have the data, the historical data. You have to put everything, and you have to even define the output, that how the output should be. But the unsupervised learning is little better in terms of if you don't have the structured output, you don't have it, you just want different patterns. But if you want to tackle the more advanced steps like gaming, robotics, and stuff like that, as I mentioned earlier, you have to go for reinforcement learning. Now, these are the basics of machine learning. Of course, there's so much more to explore, like a lot. Advanced concepts, algorithms, application, math, statistics, data science, data analysis, programming language, a lot of things. But the journey begins with understanding the fundamentals. So if you just master the fundamentals, you can watch that video that I mentioned earlier. That's in the description. Check it out. And these are the basic. So if this field excites you, there are tons of resources out there. Videos, books, articles. It's a rewarding but challenging space to break into. So be persistent, but persistence is the key. So I'll wrap up today. If you have enjoyed this episode, consider subscribing to the channel, giving it a thumbs up, and letting me know in the comments what kind of content you'd like to see next. If you missed my previous podcast, click the first video. If you want to watch me code, check out the second playlist. And don't forget to tune in next Thursday at 8 p.m. I wanted to mention that this is a weekly program that I run. It's going to be every Thursday at 8 p.m. And today I was in hurry that I made a really short video, and I'm currently working on AI, so I just thought, why not make a video on AI or podcast. Let's just talk about, maybe I'll come up with an AI agent video on my Learn With Me series. And also I'm working on a startup where we're just working with AI with public speaking and stuff like that. So yeah, there are lots of content coming in. I'm sorry for this video is kind of short, but I hope to see you on the next Thursday. Till then, take care and stay curious. See ya.